All right, so in this question here we have f of x, which I'm just going to write as y equals to x plus 1 over 2x minus 3. All right, so for this one, we want to go ahead and start by finding the 4 pieces of information: the x-intercepts, the y-intercept, the vertical asymptote, and the horizontal asymptote. Okay, so x-intercepts we can find by setting the numerator equal to 0 and solving. Right, so we got x equals to -1. So this would be the point -1 comma 0. Okay. The y-intercept we find by setting x equal to 0 and solving. Remember, we can just cover up the terms that have an x in it, and we just have 1 over -3, which is just going to be -1/3. Okay. Vertical asymptotes come from the zeros of the denominator, so that means setting the denominator equal to 0 and solving. So 2x equals to 3, so x equals to 3 over 2. So that means that it's going to be x equals 3 over 2. And then the horizontal asymptote comes from, remember we have 2 scenarios that we're looking at. The first one is, what if the degree of the numerator is smaller than the denominator? Remember, degree is the highest power of x. So in this case, the degree of the numerator is 1, as is the denominator. So they're actually the same. So the second rule applies here, which is that if the degree of the numerator and denominator are the same, then it's the ratio of the leading coefficients. So y equals the ratio of the leading coefficients. In this case, the leading coefficients are 1 over 2. So this is y equals to 1/2. Okay. There's also a tutorial on my Severn on how to deal with this kind of situation with the horizontal asymptote not just being y equals 0. But in this case right here, now I have enough information to put this together. I have a vertical asymptote at x equals to 1.5, so approximately here. I have a horizontal asymptote up at 1/2. So I've got that in there. And then let's see, I have a x-intercept at -1, so right there. A y-intercept at -1/3. Okay, just approximating that, somewhere in there. So remember, for our purposes right now, the horizontal and vertical asymptotes will act like barriers where the graph does not pass through it. Now, the graph can't pass through any vertical asymptote, but it is possible to have it pass through horizontal asymptotes. But that's really going to be a pre-cal topic. So for right now, the graph is confined by those asymptotes. So think about it as like dumping a pail of water. If I pour it down the wall, it doesn't just stop right at the bottom, it sloshes to the other side. So in this case, that metaphor helps us to figure out that, to remember that all the pieces of a rational function have to come from an asymptote and go towards an asymptote. So in this case, if I'm having to come from an asymptote, it'll have to come from here, pass through my y-intercept, pass through the x-intercept, and then get pulled right along that horizontal asymptote. Remember, it doesn't actually go into it. It's not going to hit it there, but it's going to go right along it. Now, the multiplicity of the denominator, remember, that's how many times our answer showed up. So it's the 3 over 2. It only shows up 1 time, right? Because it wasn't as if it was, the denominator was, 2x minus 3 squared. Then it would show up twice and it'd be an even multiplicity. But in this case, it only shows up once. So that means that if it has an odd multiplicity, the graph will go in opposite directions as it approaches that vertical asymptote. So on the left-hand side, it's going down towards the negative numbers. And so on the right-hand side, it's going to go up towards positive numbers up this direction. But once again, that metaphor of water here comes into play. It has to come from an asymptote and go towards an asymptote. So it'll slosh right along here. Okay? And that'll be the full graph.